Hey guys, what is up and welcome to another video. Today we will be discussing color chromatography and the science behind it. So what is color chromatography? Well, put simply, chromatography is the process by which a mixture is separated into its component parts. This separation occurs when said mixture is dissolved in a liquid, and then the liquid moves past the mixture. Because of this, the liquid is called the mobile phase, and the original mixture the stationary phase. As the mobile phase moves past the stationary phase, it pulls it along with it. This pulling of the stationary phase causes it to spread out. This then causes lighter, smaller components to move much farther than the larger, heavier components, which don't move as much. In order to understand this concept better, think a river, with the water as the mobile phase and the rocks and sediment as the stationary phase. In a river, the water is constantly moving downstream. This moving can cause rocks and stones to move as well. The stones move with the water, but not all stones move the same. While smaller, lighter pebbles might be pulled miles downstream by the river, larger, heavier rocks might be lucky to move a few feet. In this river scenario, the rocks are then separated into their different size groups by the river, with small rocks moving farther downstream and big rocks remaining closer to where they started. With this knowledge on what chromatography is and how it works, we can now start to dissect what happened in our class experiment on color chromatography. In our class experiment, we took coffee paper filters, then, using colored markers, drew a ring around them. In my example, I used the colors orange, yellow, red, and green. This ring was then used as a reference point to see how far the colors would move. After this, we folded up the coffee filter paper and placed it in a small cup of water. But we made sure not to touch the colored marker to the water, only the tip of the paper. We then stepped back and watched the show. It took a while, but thanks to capillary action and at cohesion and adhesion forces, the water was able to slowly move up the paper filter. As it did, it pulled some of the color with it. But not all colors were pulled the same. In our experiment, red and yellow for the most part stayed the same. It was green and orange that had the biggest difference. The once orange line on the paper had now turned into a smudge of red, orange, and yellow, and the once green line on the paper had turned into a smudge of blue and green. Why did this happen? Why did the once prominent orange and green turn into a mishmash of blues, reds, and yellows? What changed? The answer is color chromatography. Just as in our river example, the colors separated into their component parts. Let's back up for a second. In order to understand why the colors separated, you have to understand how colored markers are made. You might remember from elementary school, mixing primary colors, yellow, red, and blue, to make different colors. For example, mixing red and blue would make purple, and yellow and red would make orange, and so on. Well, it's this mixing of the colors that enables manufacturers to make the many different colors we find in our colored markers today. This means that for a manufacturer to make a color such as orange, they would have to mix both red and yellow pigment in their colors. This is why in our experiment that the color orange turns red and yellow. Through color chromatography, it's broken down into its component parts. But why does this happen? Well, it all goes back to the river analogy. Because the yellow pigment in the orange is much lighter than the red pigment, it moves higher up in the paper as the water pulls it up, leaving the red pigment behind. Just as the larger stones in the river were left behind, and the smaller, lighter stones were able to flow farther down the river. It is this principle which allows the once orange pigment to separate into its lighter yellow pigment and heavier red pigment. The same principle can be applied to the green pigment, with it being separated into its component parts based on weight. The end result of our color chromatography experiment is that it tells us the molecular weight of each pigment that we used. The blues and yellows, for example, were very light, although the greens and reds were quite heavy, leaving them towards the bottom of the paper. Not only did this experiment on color chromatography allow us to separate out mixtures, but it also allowed us to see and compare the different molecular weight and sizes of different color pigments. And it also made some pretty cool art. All in all, this experiment taught us a lot, from separating different mixtures to judging different color pigments based on their molecular size and shapes, and it was a ton of fun to do. And with that, guys, I think I'm going to end the video. But before I go, I want to give one last shout out to all my Patreon subscribers. You guys keep this channel going. You guys keep me up. You guys are awesome. I specifically want to call out Mr. Kim, Sean Venades, Justin Akinte. You guys are awesome. Keep on fighting. Keep on supporting this channel. You guys are awesome. Peace.